Hello everyone. Today we are going to solve one more numerical actually, to analyze the bevel gears. So this is a pair of straight bevel gears which is mounted on the shaft which are intersecting at right angles. It consists of 24 teeth pinion which is meshing with 32 teeth gear. Pinion shaft is connected to electric motor which is developing 12.5 kilowatt rated power at 1440 rpm. Starting torque of the motor is 150% of the rated torque. 20 degree is the pressure angle. Both gears are made up of case hardened steel having ultimate strength of 750 Newton per mm square or megapascal. Then the teeth on gears, they have been generated with the help of grinding process and lapping process so that they can meet the requirements of class 3 grade. Just like our previous numerical, this will help us to get the summation of errors of the two meshing teeth, the errors which occur due to the manufacturing process. In the initial stages, the factor of safety is considered as 2. Now, in the previous numerical, we had to calculate the factor of safety, but in this case, factor of safety has been already given. So let us now understand what is the requirement of this design process. So in the initial gear design stages, we have to assume that the velocity factor takes care of the dynamic load and the pitch line velocity is 7.5 meter per second. Afterwards, we have to estimate the module based on the beam strength. Then we need to select the first preference value and calculate the mean dimensions of the gears. We need to determine the dynamic load with the help of Buckingham's equation. So remember, firstly we used velocity factor, then we are also using the Buckingham's equation, and we will find out the effective load for the above dimensions, the dimensions which we have calculated in the second step. Then what is the correct factor of safety in the bending? Initial assumption was that of 2, then we will find out whether there is any correction in the factor of safety. Then we will specify the surface hardness for gears. Surface hardness in terms of BHN, that is still unknown. So we will be assuming factor of safety of 2 in the pitting failure or during the wear consideration. So overall, this is the problem statement. It might seem a very large problem, but actually when we will write down the given things, we will understand that it's not a difficult problem. This is something that we do in almost every problem. It's just that it has been asked in some different language and with some different objectives. So first of all, just like our usual practice, first of all, we will put down all the given entities. So what are the given entities in this case? The entities are the number of teeth on pinion, it is ZP, it is 24. Number of teeth on gear, it is 32. Pressure angle alpha is 20 degree. I think somewhere it has been mentioned, yes, pressure angle is 20 degree, yes. And then there is electric motor, so the power developed by the motor is 12.5 kilowatt. And then the speed of rotation, it will be coupled with the pinion, so NP will be 1440 rpm. Fine. Then there is the starting torque is 150% of the rated torque, which means we have been given service factor, so 150% per 100. So actually the value of CS is 1.5. Both gears are made up of case hardened steel, so SUT, it will be equal to 750 megapascal. Okay. Now, one thing we can do, we can immediately write down, because we have the SUT, so immediately we can write down the sigma B. So that will be SUT by 3. So immediately it will be 250 Newton per mm square. Okay. Now, once this is sorted, now we will go on for the next line. In the preliminary stages, factor of safety, which is considered in bending, it is 2 in the initial stages. Okay. Afterwards, the pitch line velocity, initially it is 7.5 meter per second. Then Okay, first preference value, etc., etc., and the initial consideration for factor of safety in case of wear failure or pitting failure, it is also 2. So the given things have been sorted out. It takes hardly 1 or 2 minutes, and then we can easily proceed for the answer. So now we know what has been given and what has not been given. So now we can proceed for the solution. Okay, so remember, the module has not been given. We will have to calculate the module from the given conditions. So first of all, let us sort down what are the given conditions available to us. So first of all, power has been given, and as we know, the kilowatt, it will be equal to 2 pi NP MT divided by 60 into 10 raised to 6. So let us substitute the values. So what do we get? The kilowatt is 12.5. It is equal to 2 pi multiplied by 1440 RPM. MT is unknown to us. Remember, we are calculating MT because we want the tangential force due to the rated torque. And okay, I will just write it down here. So from MT, actually from KW, we will find out MT. From MT, we will find out the PT. From PT, we will find out the P effective. Why? Because our fundamental understanding, like I always say, SB should be greater than P effective. This is the only thing that we need to remember. Everything else will automatically follow. So MT is not available. It is to be found. Then 60 into 10 raised to 6 in the denominator. So ultimately, what do we get here? You please solve this. I really hope you are solving this in your calc. So the value of MT is 893.2 Newton mm. So we have the value of MT available with us. Fine. So after MT, like I said, we will go towards PT. So what is the relationship between MT and PT? So if I want the torque to be transmitted, which is happening because of this force PT, then it will have to be acted through some distance. That distance is dp by 2. So first of all, it means I will need dp by 2 because now I will be having MT and this is my target. So I will need dp. So dp is equal to m zp, and like I said, m is not available with us, so I will write it m only, and number of teeth is 24. So it means that I will simply write it here. It is equal to 24m. I will substitute the same value in here. So what do I get? So actually my PT, it is equal to 2mt divided by dp. I have simply taken this term on the other side. So this is equal to 2 times mt. Magnitude is known to us, 82893.2 mt divided by dp. dp is 24m. So actually the value of PT that we are getting, it is in terms of module, it is not the final calculation value. So that is equal to 6907.77, means this term numerator will be divided by 24. So what we get here is 6907.77 divided by m. These many Newton is the value of PT as of now. Okay, we will be utilizing it somewhere. Then, like I said, we are going to focus our attention on the entity of P effective. So how do you write down P effective in the initial stages of gear design? We utilize the velocity factor CV. So how do we write P effective in terms of CV? P effective is simply CS PT upon CV in the initial gear design stages. But then what exactly is CV? So in this case, for the generated teeth in case of bevel gear, the CV will be given as 5.6 divided by 5.6 plus square root of V. So initial pitch line velocity has been specified. We can utilize that velocity. So that is equal to 5.6 divided by 5.6 plus square root of 7.5. So yes, CV can be immediately calculated. So when you calculate this, you get value of CV as 0.6716. Please do this calculation in your Calc. That practice will help you tremendously. So now in the expression of P effective, you have something about CV, you have the value of CS available with you, and you have some knowledge about PT, not the whole knowledge, but at least some knowledge. So in essence, we can now proceed towards the P effective. So ultimately, we can write the effective load on gear tooth. P effective, it is equal to CS PT, the magnitude of PT. This is what we have just calculated. So that is 6907.77 divided by M, and this CSPT upon CV. So CV is 0.6716. So ultimately, when we will solve this, what we get is the magnitude of P effective. So the numerator will be divided by 0.6716. What do we get here? P effective is equal to 15428.32, 3132 something, that will be divided by M. These many newtons is the magnitude of P effective. Fine, excuse me. Fine. So we have the value of P effective available with us. We will be, again, it is in terms of module M. So I think it will be useful somewhere down the line while solving the value of module M. Now the next thing is that, because see, module has not been given, phase width has not been given, and then because the module is not available, so that's why DP and DG, they cannot be calculated. Because of that, the cone distance A0 cannot be calculated. So the theory of Bevel gear tells us that we can assume that the ratio, this B is as good as A0 divided by 3, or we can say that the ratio B upon A0 is equal to 1 by 3. And also the relationship between the phase width and the module is, for proper gear design, B is equal to 10M. Then we will be needing the pitch angle gamma, because that gamma helps us to calculate the virtual number of teeth, so that we can determine the Lewis form factor. Why we need Lewis form factor? We will go to, for this we will go to our basic and beautiful equation, that this beam strength SP is equal to MP sigma B Y in the bracket 1 minus B upon A0. So ultimately what we are trying to do? We are trying to find out individual components of this equation, so that we can arrive at the answer of beam strength. This is our basic focus. Okay, so if you remember correctly, then I am focused on the value of SB, and then I am focused on the value of P effective. Between these two players only the entire match is being played, so we have to focus our attention on that. Okay, so as we know that virtual number of teeth, ZP dash. Why we need virtual number of teeth? Because we want to determine this Lewis form factor. So ZP dash is equal to ZP upon cos of gamma. So in the previous lecture, I have explained what exactly gamma is. So if you want gamma, presently we don't have the value. So gamma, it will be equal to, actually tan of gamma will be equal to ZP by ZG. So ZP in this case it is 24, ZG is 32. So it means that if I want gamma, then it will be tan inverse of this value. You please calculate this in your Calc. Once again I'm telling you. So you obtain the value of gamma as 36.87 degree. Done. So now we can use this value of gamma in here. So what do we get here? Already ZP is 24 divided by cos of gamma, that is 36.87 degree. So ZP dash, this will come out to be approximately equal to 30. Now we know what to do with this value. We are going to use this value and utilize it in this table. So what is happening here? Because number of teeth Z is equal to 30. So corresponding to that, the value of capital Y is 0.358. So now we will use this value. So you can simply write down that from table 17.3 the value. So we can write, so from table 17.3 for ZP dash, or for number of teeth equal to 30, we get value of capital Y as 0.358. Then now we have the value of Y. Now we can see some way or the other we have something about each and every term in this equation now. So we can substitute the values. I will again write down the equation that if I want beam strength of a bevel gear, it will be MB sigma B Y into the bracket 1 minus B upon A0. So module M as it is not known to us. So as it is, the face width B, it will be equal to 10 times module. Sigma B we have already calculated, SUT by 3. So that is equal to 250. Then capital Y, just we calculated that. We obtained that actually capital Y is 0.358 multiplied by 1 minus B by A0. We have considered this ratio as 1 by 3. So you please solve the terms in this equation except M. So M is here in this case, M is here in this case. So when you solve rest of the numerical terms available to you, what you get is the relationship between beam strength and module. So SB is actually 596.67 m squared Newton. So this is the value of SB in terms of module, but we do not know the module yet. But we know something, some beautiful relationship between SB and P effective. As we have said that SB should be greater than P effective. So if we want to replace this greater than sign with the help of equality sign, then we have to include one factor. So SB should be equal to P effective into factor of safety. And factor of safety has been actually given to us in the initial gear design stages. So it means that SP will be equal to P effective into FS. So SB, we will use this value now. So 596.67, it is equal to P effective value is something that we have calculated previously. One second, I will show it to you. So the value of P effective we have calculated here. We will use that value 15428.32. So that will be 15428.32. My mistake, I forgot to write this m square here. So 15428.32 divided by m multiplied by factor of safety, that is 2. Now you will understand that the only unknown entity in this entire equation is m now. So this m can go on the other side. Remember, it will not cancel one m from this term. It will actually become m cube. So you can solve for that m cube and all the numerical terms on the right hand side, only m cube on the left hand side. So because of that, you will get the value of m as 3.73 mm. You can either consider it as 4 mm, or for the higher magnitude of dynamic load, you can consider it as 5 mm. Both the values will be correct from the solution point of view. So in this case, just to take a different approach, we will take the value of module M as 5 mm. If you solve it by using module as 4 mm, still that answer will be correct. So the second thing that we have been asked, firstly we wanted to calculate the module, that's what we have calculated. Then we will be needing the gear dimensions. So which gear dimensions are we going to need? The first one is module, so that is 5 mm. Then we are going to need dp, that is equal to m zp. So module is 5 mm, number of teeth on pinion, it is 24, so that becomes 120 mm. and then number of teeth on gear, sorry, my mistake, DG, pitch circle diameter of gear, so that will be MZG, number of teeth on gear, so that is equal to 5 multiplied by 32, so that gives you 160 mm. So now we have DP as well as DG, so immediately we can calculate the cone distance, that is A0 or AO, which is equal to DP by 2 bracket square plus DG by 2 squared. Fine, now we will substitute the values. We already have these values. So DP by 2, so 120 by 2, so that gives you 60 ka square, plus DG by 2, so that is 160 by 2, so that gives you 80 squared. So you please calculate this. The value of A0 that you will obtain from this is 100 mm. So now you have all the terms in the equation of SB. You can directly proceed ahead. So in this case, now the main gear dimensions have been obtained. Then face width, one thing that we have forgotten, yes, the face width, it is equal to 10 times module. So that is equal to, actually, because we have taken two considerations, so we will have to proceed for it in a different manner. So the face width, it is equal to 10 times module, so 10 into 5, so that gives you 50 mm. Okay, the next thing is that we have also considered the value B by A0 as 1 by 3. So it means that P will be equal to A0 upon 3. So it means 100 is the value that we have just calculated. We can utilize it. So 100 divided by 3. So it means that the value of B will be 33.33. Now the question comes, which value should we be using? So ultimately we will be using this value of B, 33.33 or simply 33 mm, the least of the two values that will be sufficient for the gear to sustain. Okay, so value of B has been obtained. Now we can calculate the tangential force which is happening because of the rated torque. So remember, we had calculated this PT. So this PT is nothing but 2 times MT upon dP. Now dP has been calculated, so PT can also be obtained. So that is equal to 2 multiplied by MT into 893.2 divided by dP is 120 mm. So ultimately, on the basis of this, PT equal to 1381.55. Because this PT will be necessary in order to calculate the final load as well. So that's why PT calculation is necessary. Now we can proceed for the dynamic load calculation, and for that purpose I will simply first put down the main formula, and then again, just like our practice, I will break it up into individual components. So by using Buckingham's equation, I will simply rewrite it. It's very bad. Okay, so using Buckingham's equation, for dynamic load calculation, how do you calculate dynamic load? The PD, it is equal to, in the last lecture as well, we have discussed how to remember this equation. 21V component will be as it is, then you can write CEP plus PT divided by 21V, but only in this case it will be plus, and the next term will be as it is, but only the difference is that it will be in this square root bracket. So it will be CEP plus PT. Now we will do simple analysis, what is available and what is not. So this PT is available, we just calculated it, all right. And then face width B, 33 mm, out of both the values we have taken B. Then We will be needing the value of velocity. Presently we do not have the velocity. No. Then yes, we have the value of capital C, and then we have the value of error E. So the value of this deformation factor, because both the materials are same, so this will be 11,400. Then the summation of errors for both the gears, it is a small e. It is available from the data table, which means we can pretty much obtain all these entities. So we will proceed in this direction. So first of all, we will find out the velocity v. The piston is rotating at certain speed, 1440 rpm. It has some teeth circle diameter 120 mm. So we can immediately calculate the velocity. So this v, it is equal to pi dp np upon 60 into 10 raised to 3. So pi is as it is, then dp for pinion, it is 120 mm. 1440 rpm is the speed of the motor to which pinion is coupled, divided by 60 into 10 raised to 3. So ultimately the velocity v is equal to 9.048 meter per second. Now this is higher than the prescribed pitch line velocity 7.5, which was there in the initial stages. So which means the component of dynamic load will be higher. Okay, then the value of deformation factor, capital C, it is 11,400 Newton per mm square. It has been specified for the steel. Then B, it is 33 mm. Just now we have calculated. Now what about E? So E, it will be obtained from the data table. It is a class 3 grinding and lapping operation which has been done. So, and the module is 5 mm. Just give me a second. This is from the previous lecture. So this table actually provides us the maximum expected error between the two machine teeth, that is pinion and gear. So in our case, we have considered module as 5 mm. So corresponding to that, the error for the class 3 kind of machining and this grinding and lapping operation, it is 0.0125 mm. We will now borrow this value for small e. So from table we can write small e is equal to 0.0125 mm. Done. So we now have almost all the values PT, C, E, B as well as V. So now immediately we can calculate the dynamic load with the help of Buckingham's equation. Again, I am repeating the fact that the equation is not complicated. It's just that so many terms are involved, but if we practice it enough, then these terms can be obtained easily. So velocity V is 9.048 multiplied by C, that is 11,400, E 0.0125, B 33 mm, then plus PT, just we calculated 1381.55, 1381.5, here it is. So CEB plus PT term is available with us in the bracket. So this entire numerator should be divided by 21V plus, my mistake, I should not be writing V now. So that is, okay, 21 multiplied by V, that is 9.048 plus square root of, again CEB plus PT. So C 11,400, E 0. My mistake again, C E 0.0125, B is 33 plus PT is 1381.55. So not so complicated equation actually it is. So PD is equal to, when you calculate everything in the calci, 4313.31 Newton. So PT is available, so our job is done. So with the help of this PD is available, so immediately we can calculate the effective load on the gear tooth. Again remember, effective load comes from that same fundamental beautiful equation. So now effective load P effective, it is equal to CS PT plus PD. It is that simple. So CS is 1.5, PT we have calculated 1381.55 plus PD just now we calculated 4313.31. So ultimately, because of this, the effective load, it is a simple calculation. It is 6385.64 Newton. If you feel that there is some change in the decimal places in your calculator, still not a problem. 5 to 10% tolerance is always there in the answer. Now we have all of these. So on the basis of this, we have P effective. We have already evaluated all the necessary parameters, which means now we can evaluate the left hand side of the equation, our desired parameter SB. So now we can calculate the beam strength. SB, it is equal to MB sigma By in the bracket 1 minus P upon A0, because this is a bevel gear, this is not a spur gear. So M module 5 mm we have considered for enhanced safety in case of dynamic load. Then correspondingly the face width is 33, sigma B is 250, then capital Y is 0.358 multiplied by 1 minus B by A0, it is simply 33 divided by 100, or you can also write it as 1/3. Now on the basis of this you can calculate SB. Put this in the calculator, so that gives you 9894.23 Newton. Alright, so SB has been calculated. Yes, this is a bit of larger problem because so many unknown entities are there, because module itself is missing from the problem statement. That makes the answer lengthy. I agree with that, but it is not difficult one, it is just a lengthy one. Alright, so the next thing that we need to calculate, so it means that we can immediately obtain the better factor of safety or revised factor of safety. So factor of safety, it will be equal to SB upon P effective. You put the values. SB is 9894.23 Newton divided by P effective 6385.64 Newton. So factor of safety in bending, revised factor of safety, when you calculate this, it will be 1.55. Alright, so one component is finished. Now the smaller component is remaining. We need to find out the surface hardness in case of gears. So for this we will need the help of wear strength. So I will simply write down the basic two expressions of wear strength. First expression will be this simple: SW should be equal to P effective multiplied by factor of safety. Simplest expression. And second expression will be the basic formula for SW. It is in case of this bevel gears. So it will be 0.75 BQ dP K divided by cos of gamma. So now we have this value of B available with us. We don't have Q, we have dP, we don't have this load stress factor K, and we have gamma. So we will again target all of the individual values. So first of all, Q, the ratio factor. Now Q will be equal to 2ZG. Excuse me. So Q will be equal to 2ZG upon ZG plus ZP. So 2ZG is 32 upon ZG plus, my mistake, I only wrote this as ZP. I will correct because this is bevel gear, this is not the spur gear. So 2ZG upon ZG plus ZP tan of gamma. So gamma plays a very vital role in the entire solution, as you can see. So 2 into 32 divided by, this is 32 plus 24 times 10 of 36.87. So that is your Q. So Q is equal to 1.28. Okay, so one of the parameter is now available with us, Q. dP is already available. We need to have the value of K, because if both the pinion and gear, they are made up of the same material, then K is equal to 0.16 BHN upon 100 bracket squared. We will simply put this value in the equation of SW, because anyways BHN is not available. That's the actually target of our solution. But then we also need to have this value of SW, because it cannot happen, remember, it cannot happen that SW will be unknown, this K will be not known, because BHN is not known to us. It cannot happen. So at least we need to have the answer about SW. So that will be obtained from this step. So SW is P effective into P effect, sorry. So SW, it should be equal to P effective multiplied by Fs. So it means that if I want SW, so we have already calculated the effective load, 6385.64. Fs is 2. For wear consideration also it has been given as 2. So that's why we can take it. So it means that SW, it is equal to 12771.28 Newton. So this is the magnitude of SW. Now we can use this in the second equation. I will now write it down. So SW, it is equal to 0.75 BQ dpk divided by cos of gamma. So I will write it down, 0.75 B, it is 33 mm, already given, already calculated. Q, we just obtained 1.28 BQ. Then dP is 120 mm. K can be taken from this term, so that is equal to 0.16 multiplied by, actually now this will be BHN squared divided by 100 squared divided by, still one thing is remaining, cos of gamma. So gamma is 36.87. Remember, both of these terms, they are in denominator only. Don't make any kind of mistake while putting this in the calc. And on the left hand side, we have actually the value of SW, 12771.28. Then you take both of these terms on the other side and divide that resulting term on the other side, in the sense you can multiply it here, and then this entire term, it will divide that product, so that you will get BHN squared, and you can then take the square root in the calculator. So ultimately the value of surface roughness which comes out, BHN, it is equal to 409.84, or it is equal to 410. That's the value of BHN. So remember, actually we did not do any kind of rocket science. We only applied our basic understanding. What was the basic understanding? Only in terms of two equations, that SB should be greater than P effective and SW should be greater than P effective. And then we broke up this basic understanding into its individual components pertaining to the condition given to us, and then we arrived at the final answer after calculating the module. So I hope this explanation was useful to you. Thank you.